Hello everyone and welcome to my channel. So what question we have today? Today we have this question: which of the following complexes will show coordination isomerism? Okay, so we have been given 5 options and a pair of complexes, and out of which we have to select the complexes which show coordination isomerism. So I hope if you have some understanding of the coordination chemistry, especially the isomerism part, then you must have learned about different structural isomers like hydration isomerism, coordination position isomerism. Now, which complexes show coordination isomerism? As the name suggests, coordination, that means that has something to deal with the linkage of the ligands. So basically, coordination isomerism occurs in those complexes where there is an exchange of ligands, and especially the cationic and anionic complexes. So we have cationic and anionic complexes, and the ligands exchange their positions. And also there is a possibility of the metal ions, the central metal ions, to exchange their position as well. So either the metal ions or the ligands, they will exchange their places or the coordination. Okay, now we can see here that in option A we have same central metal atoms with different ligands, and also in option C we have same metal ions, cobalt, with different ligands. In A we have silver with 2 different types of ligands, and in option C we have cobalt with 2 different types of ligands. Actually, when the metal ions are same, then if we exchange ligands, when the metal ions are exactly similar, then we get same complexes. Like if you exchange the ligands in option A, then you get again the same complex, AgNH3 whole twice and AgCN whole twice. Okay, there is no difference. So mostly when the central metal ion is same, coordination isomerism is not observed. But having said this, that the presence of metal ions, when same metal ions are present, there is least probability of getting coordination isomerism. But at the same time, there are few examples where we have the metal ions which are same, but still there is a possibility of getting the coordination isomerism. You can see here this example. We have 2 platinum complexes, one with amine, another with chlorine. Okay, and in the second pair, so this is the first pair of the cationic and anionic complex, and in the second pair what is happening, one amine ligand is shifting to the second part and one chloro is also shifting to the first part. So we have an entirely different structural formula, which is PTNH3 whole thrice Cl, which is entirely different from PTNH3 whole 4, and also in the anionic complex PTNH3 Cl3. So there is this possibility in some of the complexes where the central metal ion is same. So this is a particular specific example. But in our given options, there is no such possibility. The best part is we have to eliminate option A and option C, since we have same central metal ions, and we have to see the rest of the options B, D, E. So cobalt, NH3 whole 6, CrCN whole 6. Yes, there is a possibility of formation of coordination isomerism. Like if we write something like this, CO CN whole 6 and CrNH3 whole 6. So this is one possibility. Okay. Then we have for iron, we have FeCN whole 6 and cobalt NH3 whole 6. Okay. And also for the option E, we have COCN whole 6 and FeNH3 whole 6. So all of these, option B, D and E, all of these can form coordination isomerism by the exchange of ligands. So I hope you understood that how these coordination isomerism are formed for option B, D, E. So our answer in all probability should be B, D, E. So option 2, this option should be our correct answer. Only B, D, E only. Okay, not A and C, because A and C, if we exchange the ligands, then they will form the same complex. There is no difference in their structural formula. And in addition to this, there is also a similar similar named isomerism, that is coordination position isomerism. So this coordination position isomerism is also happening because of the exchange of the ligand positions, but it is mostly observed in the bridged complexes, not these normal simple kind of complexes, but bridged complexes where we have two metal ions bridged through a ligand, and then we have additional ligands also which can exchange positions across the complexes. So please do not confuse between coordination isomerism, okay, coordination isomerism and coordination position isomerism. Both are different types of isomerism. Both occur through exchange of ligands or the metal ions, but coordination position isomerism is specifically found in the bridged complexes. And all these basic concepts of coordination chemistry, which deals with isomerism, that you can find in my Udemy course, Concepts of Coordination Chemistry. You can just check it out and you will find all kinds of isomerisms and the basics of coordination chemistry covered in that course on Udemy. I hope you understood the explanation. And if you have any doubts or queries, please write to me in the comment section. And also, please do not forget to like, share and subscribe if you find my videos helpful to you. And till then, thanks for watching, keep learning and see you soon in my next video.